In this video, we will learn interfacing switch to a 7-segment display by using FlowCode. First, open FlowCode and select 16F887 PIC microcontroller and configure it at 4 MHz clock pulse and internal oscillator and RE3 pin as digital input-output pin. Okay. Now, in output, a 7-segment display here. Go to the external properties. It is a common anode 7-segment display. And change the color of the 7-segment display. Increase the size. Okay. Go to the input and put a switch here. Go to the external properties and change this push switch to push button switch, and it is momentary push button switch. Okay. The connection of 7-segment display, common is connected at port 3 and segments are connected in port D. Okay, done. Switch, the switch is connected at port A, port B, any port of the microcontroller. Okay, port B0. Now getting an infinite loop, call a component macro. First, we have read a switch value to a variable. First, add new variable. The name of the variable is SW and its initial value is 0. And read the switch value to the SW variable. Then I am check the switch is pressed or not. So SW is equal to 1 or 0. If it is 1, then I am convert the digit to a variable. So I new a variable, this is a variable and its initial value is 0. Okay, and put the a as a value of the digit. I'm calculation the a, that is increasing. The a is increased 1 by 1. So a is equal to a plus 1. When switch is pressed, the value of the 7-segment display increase 1 by 1. Take a delay of 500 millisecond. Okay. If switch is does not press, then only show the value. The value stored in variable a. And decimal point value is 0. And I've run it. First value shows 0. And press the switch, it is changed to 1. And another press the switch is changed to 2. When I'm pressing the switch, the number is increment 1 by 1. Up to 9, it will be increment. After 9, it is not show the digit here because there is 1 7-segment display. Now file and save it. Take a name of this file. Save it. After save it, compile it to a hex file. Then I'm going to Proteus and select 16F887 IC. And a display and a button. First button. After that, a resistance is required. So select a register. And a 7-segment display. So I search a display. Here I am search a 7-segment display here. here is a common anode 7 segment display. And select it. Okay. Now first put the peak microcontroller here and 7 segment display. Put a button here and a resistance. Now connection. Button and resistance connect in series. Between button and resistance, and connect it to a port A0 pin. And ground and VCC is needed to the button and resistance. And connect it. Now connection of 7 segment display. The switch connection is port V0 pin. Okay. The switch is connected to port V0 pin. So 33 number pin is connected to the switch. And connection of 7 segment display is common is connected to port A3 pin and segment are connected to port D pin. So common is connected to port A3 pin, that is 5 number pin, and port D is connected to 7 segment display. Okay, connection complete. Now I am compile it to hex file. Wait some time to compiling. After compilation finished, close the window, go to Proteus, make the frequency as 4 MHz and put the hex file here. Where I am save it, the hex file is there. Okay, now I am run the Proteus now. When I am run the Proteus, the value of the sensor is show 0. Now press the button, the value is increase 1 by 1. 6, 7, 8, 9. Okay. Now I'm change something here. So what can I change here? And take one or decision here. The decision is take a new variable b. No, what? No, it is not needed. Not new variable. And take a variable a here. And check a decision a becomes 10 or not. If a becomes 10, it is automatically convert to 0. If a becomes 10, it is converted to 0. So I have a decision making box here. No, the component macro is not needed. You have calculation box is needed. And calculation is A converted to 0. When A is 10, A is converted to at 0 position. Okay, and take as delay of here as 500 millisecond delay. Now run it. When press the switch, the number is increment one by one. 7, 8, 9. After switch press, it is goes to 0. No, it is not goes to 0. So I put a wrong here. Wrong decision making. If A becomes 9, then it will goes to 0. So not 10 here. So A become 9 here. Now 1, 2, the number is incremented. 6, 7, 8, 9. Then I press the button, it will become 0. Okay, then it's 1, 2, 3, 4, 5, 6. Okay, now compile it to hex file and check it in Proteus. This is a called up counter. It is counting 0 to 9. This is up counter when I press the switch. Now when I press the switch, 1, 2, 3, 4, the counting is up in 7, 8, 9. After press, it becomes 0. 1, 2. The switch is counting from 0 to 9. Okay, now go to Proteus and take another switch to counting downwards, means down counter. This switch also a push button switch, and this is a momentary switch. Increase the size of the switch. Okay, the small switch is up counter and big switch is down counter. Now I'm check a decision making box to second switch. Now where the decision making box is needed, this switch is up counter and this switch is down counter for yes. If the first switch is not pressed, then check the second switch is pressed or not. So I'm take a new variable, it is switch SW1, initial value is 0, and check SW1 is equal to 1 or not. When the first switch is not pressed, then check the second switch. When SW1 is not is equal to 1, then the counting is downward. If it is not pressed, then only show the value of the in the second segment display. If it is pressed, then the digit is A is shown in the box and calculate the digit A is equal to A minus 1. So I made a calculation here. A is equal to A minus 1 to decrement the value of A. And delay here, I make a 500 millisecond delay. Now run it. When I press the small switch, the number is incremented. When I press the large switch, the number does not decrement. Why does not decrement? There is some missing here. Oh, I cannot read the second switch. I am read the first switch, but I cannot read the second switch. So first I am read the second switch here. I am read the first switch here, but I cannot read the second switch. So second switch is read to SW1. First switch is read to SW and second switch is read to SW1. After that I am run it. First switch is 1, 2, 3, 4. Second switch is decrementing 4, 3, 2. If first up counter is pressed, then it is incremented 1 by 1, goes to 9. After it is goes to 0. And down counter switch is pressed, then it is decrementing. And compile it to hex file. Connect another switch in the Proteus, then check it. Connect another switch here. Now copy this branch. No, that's not possible. Copy this branch to another position. Here. Okay. Now where the second switch is connected, go to the flow code. The second switch is connected at port A0. Okay. Now second switch connection goes to port A0 pin, means pin number 2. Okay, I'm run it. When first switch is pressed, the value is incrementing. 4, 3, 5, and second switch is pressed, it is decrementing. 1. Okay. Now some changing. Here, when I press the up counter, it will increment, and press the down counter after 0, it will goes to nothing. So I need to change it here. Need some change here. Make another decision making box here. Check the value of A becomes 0 or not. If A becomes 0, then the calculation here, if A becomes 0, then calculate A is equal to 0 and delay here 500. Okay, and if A not equals to 0, then this is happen, the decrementation. Now run this. The incrementing switch is okay, perfectly work. Incrementing decrement switch perfectly work, and it goes to 0. When I press, it is not decrementing, it is 0 in the 7 segment display. After 0 it is not in decremented. Now I'm compile to hex file, check it in Proteus. I'm going to Proteus, run this. When I press the up switch, it is counting up. When I count the down switch, it is counting down. When it is goes to 0, if I press the switch, it will not change the value. It will always show 0 here. So I'm making another change. When it is 0, when it is goes to the position of 9. Okay, let's check it. When it is up count 1 2 3, and what is down count 2 3 2 1 0, after press it will becomes 9, after 8 7. Okay, now compile to hex. The up counter is counting from 0 to 9 and down counter is counting 9 to 0. When is up counting after 9 it becomes 0 again. When down counting it is goes to 0 and become 9 again. Okay, goes to Proteus and check it. Run the Proteus, the up counter, and the switch is pressed 1 2 3 4 5 6 7 8 9 and then 0, then 1 2, and it is repeated. Up counting is repeating. When I press this switch is down counting 2 1 0 and goes to 9 8 7 6 5 4 3 2 1 0, and it is goes to 9. Okay, thank you.